Hello, Daniel here. I'm going to be talking today about set and map. They're really cool, and I'm trying to get my head around how and when to use them versus like an object or an array. So I have a few examples laid out here in code. A lot of good comments, and I'll leave a link to this code in the description below. Let's dive into this. So plain old JavaScript objects, POJOs, we all know and love these. We use them all the time. But they weren't really made for mapping over and like iterating over the values. There's this new function called object.entries that gives you like the key and the value so that you don't have to actually reach outside. If you like, normally how you map over an object is using object.keys.map. Entries is a cool way to do it. But as we know, on an object, it's like a hash. You hash directly into a key, and accessing is very, very fast. So what's the difference with map? Map is a list of values the same way object is, a key value pairs. You kind of initialize it with this iterable thing that looks like tuples. And the cool thing about map is that it's made for iterating over. You initialize with an iterable. It kind of understands the order in which things were inserted, and you can has all these built-in convenience methods to clear out the entire list, delete an item, check if it has an item, set an item, and loop over. So here I'm checking if it has age, and if it doesn't have age, set it. That's easy. It's a little bit clunky with a regular object, and it has this nice for each function, which we're used to on arrays, and it just gives you the key and value. It's very nice and easy. And so it is actually slightly slower for direct access though, so be a little careful, but these are really nice if you're ever needing something that's somewhere in between an array and an object. So then what's a weak map? Weak map is the really interesting, cool thing. What weak means is if all the references except for this reference to a certain object disappear throughout your program, you only have this one reference left. It weakly holds it, which means it's going to let it go when the next garbage collection comes through, and it's going to be removed automatically from your map. So in this case, I've set the properties so name and age instead of just being a string or an int. The values and all of the keys in a weak map have to be reference objects, because that's the point of it. All of the keys are weakly held. So your key is always an object. This is a little strange in an object. When we think about regular objects, usually you don't have an object as the key. But in this case, all of the keys must be objects because they're references. So in this case, I'm deleting that object that I created name. And if I set timeout to ensure that like garbage collection happened, and I try to access that thing again, we'll see it's just gone. So this is useful if you're ever mapping one thing to another thing where the key is an object, right? So if you have a list of DOM nodes or something, and you want to attach some metadata to each one in this object that lives somewhere else, your key could be DOM nodes. And then when those DOM nodes are no longer referenced in the real DOM, that node will automatically get removed from your list. So there's some interesting applications there. I wouldn't use that every day, but I know some people do and really like it. So then what's a set? A set is more like an array than an object. So if you think of a regular array, a set is basically an array with just unique values. There's not much more to it than that. It also gives you these nice convenience methods for add, clear, delete, for each, has. And it also lets you know the order in which things were inserted. One cool trick you can do with set is you can use it to filter out all the unique values from an array. So here I've made a test array with a bunch of duplicate values. If I just throw that into a new set, that will be a set of just the unique values. So this can be pretty useful for little utilities where you're just trying to have a unique set of things and then see if they exist. If you ever had the situation where you're using an object, you're using a hash where all of your values are just booleans of like whether or not that thing exists or not, that's a good indicator of that you can replace that with just a set. It's basically the same thing. So then what's a weak set? So similar to a weak map, a weak set holds the references to all the things in the set weakly. The only difference is there's no associated value. It's not a tuple, it's just a list of references. And whenever one of those references is no longer referenced anywhere else, it automatically gets pulled out of your set. Fairly simple here. So here I'm initializing a new weak set, throwing in the same name and age that are objects. This HackerRank thing is just a dummy made up object that already exists. And if I check if it has those references, I can check if, basically what that's checking is not only is it in my weak set, but is it referenced somewhere else in the system still? It's kind of an indicator. It's not exactly accurate because you can't tell when garbage collection is going to run or not. That's why I have to do this set timeout thing again to delete it and then do a set timeout to see if after garbage collections that it's actually been deleted. But it's kind of a cool indicator of that. I couldn't think of like a really good example where I've used it, so if you can think of one, let me know. One important thing is there is no get here. There's only iterating over it, and there's a has. So here I'm checking if it still has the value, and that's going to return false because I deleted it and waited for 2 seconds. So another really interesting thing that I found out when I was kind of researching the differences between these things is that they are all initialized by an iterable. And what does it mean to be iterable? Well, there's this really cool thing where you can make any object an iterable by telling it how to iterate over your objects. And you can do this with symbols. If you haven't heard of symbols before, I have never used one in like real production code. But what they are is a way to get an entirely unique value. So here I have this unique person, and you can give a unique name, just call symbol, and then you get like a globally unique value. And you can also just pass in a random string, and it's always going to give you a new unique value. So symbol foo will never be equal to symbol foo. But if you use the word for with it, this is an exception. Symbol.for is like kind of the opposite. It's globally always going to be the same, even across all of the memory space of the browser, so iframes and tabs and everything, which is really interesting. So there's all these symbol functions that you can use for modifying objects to make them do interesting things. You can tell it how to handle a replace function. You can tell it how to split your object or how to search your object. And essentially you can conform to the other APIs of the language by implementing these symbols on any random object. So in this example, I have this iterable person, has a name and age, and I want to say, instead of just a regular object, I want this to be an iterable. So I made this crazy thing. I didn't even know this was possible or a thing. I just started trying to do it. So I have the symbol.iterator is the key. It's a function, but it's going to yield values that to say like on getting the next value, this is how you iterate. So this is how iterators work. They work in conjunction with generators. So this is an inline object generator function using a symbol as the key. This one line 146, it just like blew my mind. In this example, I want to always trim the name when I'm iterating over it. And then I can just new up a map with that thing. And map knows, or it understands because of the API of iterators, how to iterate over this thing and make a new map out of it. Hope you like this video. Let me know if you have any ideas for other stuff you want to see me kind of go through. And have a good one. Keep on coding.